Howdy, folks, and welcome to your storm chasing forecast show for Friday, August 21st. I am Gabriel Harbor, and I'm once again joined by our newest coaching addition, Andrew Shearer. Drew, how you doing, man?
Doing good. How about yourself?
I'm doing great, and you are fresh off the heels of an excellent forecast from yesterday. I have to hand it to you, give you a little golf clap there because definitely had a little bit of a dicey situation in a populated area over near, I believe it was Dover
Yep.
yesterday. And you were mentioning that it might get upgraded to a 5% tornado risk. And I think it actually went beyond that, right? There was, I think, a SIG 1 that also got added.
A 5% SIG 1 was issued. There's no way I would have done the SIG 1 last night, but 12Z runs and were showing much more low-level shear. So I understood it. I wish SBC said a little bit more about it, but I understood it with the model guidance coming in.
Very nicely done on catching that uptrending of events. And we're back for round two here. Everybody in our forecast show chat was like, "Oh, sorry, I can't do a show tonight." I think the Never Stop Chasing premiere was going on. A couple of our coaches were out with that. So
Yep.
I really appreciate you being willing to jump right into the fray, pick up the slack, and I'll leave it to you to give us a rundown of the categorical there. I see you've already got it up on screen.
Yes, I do. So as of currently, the current outlook has actually the main risk focused on the Central Plains. But interestingly enough, the only tornado risk for the entire CONUS, I zoomed in on it, but just to show you I'm not crazy, is by the Chicago metro area. So it's actually within a marginal, and I'll get into a little bit of details again. I think we may get a perhaps an upgrade later on. Again, not as clear slam dunk synoptically as the setup that happened yesterday. However, going to the ensemble. And so I have the 500 millibar flow and the 850 from the HRRF, the latest version of that. So this is right around 230Z. You notice that the main wave, at least on the ensemble, is further to the west considerably. But there is a response at 850 associated with this trough that's moving through. And so actually looking at deterministic runs, unfortunately, I had a drawing, but it didn't want to save, but that's okay. You see this main speed max that's very clear on most guidance, deterministic, ensemble, regional, globals. They all have this speed max moving through the central plains, which is clearly responsible for the main severe risk being focused over here. But particularly looking at some of the latest cams, you see a little bit of a disturbance here. And I'll actually draw here to illustrate this. This is actually a straight speed max if you want to do this. And let's say this is probably close to the midway point. We're in, so the tornado risk is about in this area. It's not precisely drawn, but it's in that area. And so you're within that left exit region of the jet, which is generally associated with upward motion. You would be looking for the right entrance and the left exit being your regions of ascent. Also, some of the keener eyes of people will notice that there is a little bit of a kink that's going through the area that will also provide ascent more so for the severe risk that we're focusing on with the tornado risk compared to where there's a much stronger region of ascent associated with the main slight risk further to the west. So we do have synoptic scale ascent, and we do even have a low-level response, which tells me that we are not probably going to be struggling with lift, at least in the synoptic sense. We'll take a look at stuff more at the surface here in a second to see if we have some very evident boundaries and such like that. But we do have synoptics that do favor severe weather. So that's something to keep in mind.
Drew, I love the drawings, by the way. And if folks are at home right now thinking to themselves, I too would like to actually draw up my forecasts like this before my storm chases, That is the WeatherFront app in all of its glory that you are looking at on his screen right now. It actually just released for Android after everybody has been waiting with anticipation for so long, and they've got a special deal for all of the Android users. So not only do you get the 7-day free trial when you first sign up if you've never joined the app before, you're also going to get 50% off your first month as a celebration for Android finally coming out. So link in the description to check that out, and then once you've set up your account on your mobile device, you'll be able to use that to get access to the browser app and to the desktop app. Again, that's the link down in the description. And Drew, if you want to take us down lower in the atmosphere, let's see what's going on today.
All good. So I actually wanted to look at the Deterministics 850s, not just the ensembles, to see if we're getting some muted. First thing you notice, over the main severe risk, there's clearly some activity associated with what is likely to be an MCS by 2122Z. You can really see that appearing fairly well, at least on the HRRR. But notice over the region, we have westerlies to southwesterlies, and that's depicted on most cam guidance. Not particularly strong, especially earlier in the day. However, it does increase towards 0Z as you generally would expect. Similar magnitudes, if not slightly stronger in comparison to what happened in the Delmarva region, actually. The direction is a little bit different, and you have to orient yourself differently. We had a southwest trough or a southwest flow with a trough moving through the mid-Atlantic. This is northwest flow, and it's not pronounced weight. So having flow coming from a different direction makes sense because your dominant flow aloft is coming from the northwest. The atmosphere is very simply, winds in the atmosphere are in response to temperature gradients. So when you have southwest flow, you tend to have gradients that are more oriented north-south, like cold fronts. However, when you have northwest flow, you tend to have boundaries that tend to sag more east-west. And so you get differences in responses and such. And that is the reason for the different winds. However, just because the winds are different doesn't mean you can't get a severe threat. And in fact, there is a pretty prominent severe threat. So wanting to go down to the surface, so I'm showing currently the 0Z HRRR. And what you notice, this is 4 p.m. There's not a really pronounced boundary. You do have a wind shift and perhaps even a convergence zone focused on this region in particular. Comparing this to other models, again, more of a convergence zone that is occurring over the area rather than pronounced, like very sharp dry line or a very sharp cold front. And I'll show surface temps here in a little bit to show that again, we're dealing more with a surface trough, which is a little bit more subtle mesoscale ascent. And as a result, that would favor more discrete mode. So actually, I will show you right now the 0Z HRRR. So this is convection, or I'm pretty certain is convection. But notice where this wind shift is. 86 here in Cedar Rapids, 82 here, 70. This is fairly likely convective feedback. And in fact, looking at other guidance, it confirms that. 69 at 2 p.m. in Rockford, I'd be shocked unless there is something that I am completely missing in my forecast, which it does happen even to people that have been doing it for years. The NAM is a little bit cold generally, but you don't notice, again, this very sharp temperature gradient, which would favor perhaps more of a discrete mode. So I'm going to use the HRRR as a reference here, and you kind of get in this region kind of a weak convergence zone, modest wind shift in this area. There is a surface low further north, but it's again not overly pronounced. And let's just say, looking at the dew points, that we want to focus on kind of this region where there's the best convergence and perhaps just a subtle boundary. If you take your wind shear vectors, it's oriented almost perpendicular, which would favor a much higher likelihood of a discrete mode. And this angling is fairly consistent across most, if not all, guidance. That is pretty common in northwest flow, especially when you deal with more subtle forcing in the synoptic. compared to a pronounced wave that dips in. But you do get much favorable modes of supercells. One thing that you tend to lack, though, in response is low-level shear, which we'll get a little bit into it. We actually noticed a little bit of an uptrend with the latest runs. So looking at instability, we have plenty of it. This is MLCAPE. I tend to favor MLCAPE because surface-based CAPE, you can sometimes get very weird high spikes with the values, so I choose to not focus on it. But we're getting MLCAPE. I'm guessing I don't have a color bar actually present, but I'm guessing this is around 2000. Let's take actually a sounding by Davenport at 5 p.m. local time. It is 3000 MLCAPE, which is a lot of MLCAPE, especially in late August. And if you notice, you have also 0 to 3 CAPE is very high. I could believe that with these low-level lapse rates in place. So that's favorable storm mode, that high instability, especially in the lowest level, with these steep low-level lapse rates, with modest for the region mid-level lapse rates, but sufficient. We were talking yesterday about Dover's area. They got it done with mid-level lapse rates of 5.8 degrees Celsius per kilometers. So getting closer to 7 is certainly enough for severe weather. And generally, again, across all the guidance, pretty high instability that remains in the picture throughout the event, with storms likely firing, I would think, in this kind of tri-state area of eastern Iowa, northwest Illinois, perhaps into southwest Wisconsin, would be the area that I'd be focusing on for initiation, probably around 4 to 5 p.m. More discrete, more isolated, similar to actually what's happening or what happened up here today, which would again favor that supercellular mode. The big thing is tornadoes, but there was a noticeable uptick in the presence of a 0 to 1 SRH over the vicinity compared to the 0Z runs. This is actually probably a pretty good depiction of what is way better low-level curvature in the area. And this is a classic northwest flow sounding, where you get maybe just a little bit of backing at the surface, and then everything comes out of the northwest. So even though your 1 kilometer flow is almost due westerly, it's sufficient for tornadoes, for sure. Especially when you get 0 to 500 meter SRH over 100, you most certainly can start talking about tornadoes, especially when your LCLs are sub 1,000. So the big question will remain coverage because, again, we have more subtle boundaries. But with that synoptic scale ascent in the area, I would expect at least isolated, if not widely scattered supercells across this area. And initially, very large hail would be favored with these supercells. There is a dark horse play further here. However, you're in between the two systems. So you are in that left exit region, but there's a wave that's responsible for this system up here, which you're getting the low-level response, and then more of a pronounced wave further south for the slight risk. So you're in this in-between zone of ascent, and that could lead to very isolated to perhaps even downward motion, isolated coverage via downward motion across the area. So there is a risk here, but I would be more focused on the tornado risk here, or if you're chasing perhaps the initial supercells somewhere in Kansas before they grow upscale. Although with high LCLs depicted and outflow growth pretty prominent, the tornado threat should be focused particularly over northern Illinois.
Before I ask you a couple of questions, Drew, I want to remind folks that we have a channel membership. It's right down below this video. You just click the join button and you're going to get access to some awesome perks. But most importantly, it's a way you can show your support for this channel and these forecast shows in particular. We only plan on ramping these up as we move into the storm chasing season for 2027. So if you want these to stick around and continue coming out every single day, please let us know. It's $3 per month. Like I said, awesome perks. Check it out down below, join button. Drew, first question I have for you is whenever I see a severe weather setup that is right by one of the Great Lakes, I'm always wondering how does this large body of water potentially come into play? How can it affect our setup, or does it at all?
It most certainly can, although probably at this time of the year, the lake has warmed up. So this was actually really pronounced for the Kankakee supercell, where if it is early in the season, the lake is still very cold. It could even have ice, but the air temperature is in the 70s or 80s. So you get a pronounced lake breeze. And as a result, that baroclinic zone, first off, can serve as the northern delineation of where severe weather can occur. And two, that area could be a focus for perhaps enhanced tornado genesis. So actually looking at the air temperatures, if you look over the lake, they're a little bit colder, but I'm looking here to the east where, because you have southwesterly that's coming right off the lake, it doesn't seem particularly pronounced. Like I said, we'll look at the cams. I think this is convectively induced cold air. We could take a sounding as a result. So if this is not convectively contaminated, or there's a lot of downward motion, so it might be right behind where the storms are occurring. If this was March or April, the lakes could have a much larger impact on the severe setup. By mid-August, you would expect the lake to have warmed up to probably close to the maximum temperature it's going to get. So it won't have as much of an impact, but you could still have some boundaries that form in the area if no synoptic boundary overrides them. And those could be focal or focused areas of local ascent. If we zoom in, perhaps this is a hint on the HRRR of some sort of lake breeze, and perhaps that could be a focus corridor of perhaps enhanced severe weather. But that's largely guidance with how it performs is largely suspect. And so that is more of a nowcast analysis day of type of situation. So
And then what does it mean when you say, I'm not sure if I remember the exact phrasing, but something like convectively altered or enhanced or augmented? What does that mean when you're talking about how the convection that's ongoing can alter the local environment?
I'll actually, just for the sake of demonstrating it, I will show what the HRRR is doing at this time with reflectivity. Yes, so that makes sense. So what is going on is we have this very large cluster of storms depicted on the HRRR that's moving through the Chicago metro really early by 4 p.m. And if you notice, the temperature behind it is cold because what convection does, the atmosphere hates being out of balance. The atmosphere wants to be in balance. When you have 3,000 MLCAPE uncapped, it is unstable, and the atmosphere will do everything to stabilize it. How does it do it? Convection, because what convection does brings cold air aloft to the surface and warm air up, and it reduces the temperature gradient. There is the concept of temperature gradients is the response of many things in the atmosphere. Your speed maxes are in response to temperature gradients, convection's in response to temperature gradients. Everything is just temperature gradients, and the atmosphere hates it. It likes being in geostrophic balance where it doesn't have to worry about these temperature gradients. So it creates this convection to stabilize this instability. And that's what happens is the convection augments or actually alters the environment that is there. So for example, I will show here this sounding. You have negative SRH, which is not what we were looking at. But if you go south of this, which is more reflective of the actual environment, you do. This is fairly early in the day, so take it with a little bit of grain of salt. But you have that much higher instability that's present compared to regions that are directly impacted by storms ongoing. So that's what I mean by augmented or convectively modified is another term that's used.
Really appreciate the explanation. That makes a lot more sense now, and I know there's a lot of folks that are watching. That's one of those questions they probably have on their minds when they're reading the SPC outlooks, but maybe they just, for whatever reason, don't ever get to ask anybody to explain it. So very cool stuff. And that will take us to the final segment of the show, which We were, of course, calling it Cam versus Cams when it was Cameron Nixon on the show, and we'll do that again in the future. But I'm thinking we need to have something kind of snazzy to call it when folks like yourself are on here. So I was thinking something like CIMREF Showdown has a
That
nice ring to it. What do you think there?
that could work. So that I have no problem with that for sure.
All
So
right, let's go ahead and get right into the CIMREF Showdown and see what the cams are laying out for us.
so immediately catching my eye, let's check current radar, what it looks like up here. So paying attention to this seems like a factor. So there's clearly a disturbance here. You actually can see the spin in the atmosphere that's ongoing. And there were actually some isolated discrete supercells that formed in this area. And in fact, yeah, you can see that there was some areas of rotation and some mildly severe hail. But what I immediately saw is I saw a lot of convection on cams. So this is this is 9 a.m. on the northern edge of the risk. So there's clearly a disturbance that's being depicted that moves through. So unlike what we were talking about in Delmarva yesterday, we have Ascent very clearly ongoing. This could be a fly in the ointment that leads to complications in the forecast. Absolutely could be. It looks, this is fairly early for storms to be doing this. 11 a.m. local is really early. So that flow aloft is displaced further over here before it gets in later in the day. So that is one thing to pay attention for if you're chasing, is that dreaded morning convection screwing up the setup. Now, one model, the FV3, which I have huge suspicions about for a variety of reasons, keeps the area mainly dry. So this could be like a higher end solution that occurs, although it looks like it's displaced further north. But if there's earlier convection, it may favor more messier wind-driven stuff. Although I did notice this secondary development that occurs on most guidance further to the north, that trip or tri-state area that we were discussing. And the NSSL has a giant supercell by Davenport, but I will also take that with a grain of salt, as most guidance, I think, might be dealing with what we were talking about, that convectively augmented air, limiting the setup compared to what it could have been. So the main area that I would focus on, perhaps, is if this develops into an MCV, what happens ahead of it? If you can perhaps get some sort of spin up associated with an MCV aloft that moves through, that would be one thing I would look for. In fact, we'll just very briefly look. I wonder if there is. So yeah, there is some sort of MCV or some sort of upper air response with this convection that shows perhaps you get development of an MCV. But again, that main flow aloft is displaced to the west. So this could be a situation where this ascent is coming in a little bit too early, perhaps very too early, could limit this setup overall. So that's one thing to keep an eye on, which I did not actually check for morning convection before we discussed, because it was not there when I was looking earlier today. So I did not think there would be such a dramatic change, but there was. So these supercells that fire back here are likely in that augmented air, are probably elevated and not surface based. Yeah, you can see this very large kink in the surface temperatures from that augmentation. So these storms would be very good at producing hail, perhaps some structure, but not very good at producing tornadoes, even though we actually have good low-level shear because the storm just couldn't be surface-based. So a lot of the cams suggest this redevelopment behind that morning/early afternoon cluster, with the exception of the NSSL HT. But some guidance does keep it relatively. This is a lot of convection for with the exception of perhaps the NSSL version, which is the 18Z. I'm curious. This screams problematic for tornadoes. Just too much convection, way too early. You would want this closer to peak heating or at 4 p.m. Or perhaps, again, if we get an MCV that develops, that redevelopment could be a focal point. But I do see why the cams are actually firing this region of Ascent is there's a pretty pronounced wave that moves through and it just follows it all night into the morning. I bet you there's even a low-level jet response. Yep. So it's forming on the nose of this low-level jet that moves through. And in fact, your convection is just forming right on the trough of this 850, basically trough, 850 trough that moves through. It might even be a little bit more pronounced at 700. Yeah, you have a pretty pronounced wave that moves into the area as well. So with this amount of scent before peak heating and with minimal capping, like none of the soundings we saw, it's going to be very difficult to prevent this morning convection. However, if it doesn't happen, then a higher severe risk could be realized. So I will actually go back on what I said earlier with the 5% upgrade being possible. It's probably unlikely unless this develops a very certain way where it's not contaminating the environment for what would be the better round of discrete later on, which to be determined whether that happens or not. But there is a chance. It's, I would say, lower chance than I'm not as confident in a clear warm sector compared to yesterday in Delmarva, but there is a chance of severe weather and a couple tornadoes possible within the Chicago metro and surrounding areas, perhaps back towards Davenport as well. I think this area might have avoided the majority of the morning convection. So this is just occurring because it's 0Z. This is nocturnal cooling. It's actually not convectively contaminated. This area could be ending up being the darker play. So if the morning convection moves through the Chicago metro, I wouldn't be shocked if you see perhaps, I will draw this, some sort of trailing outflow boundary that forms perhaps like this, kind of this idea further to the west that shows up on most guidance. And it shows up actually fairly well in the HRRR, the H or the NAM and the Rufus and the MPAS Rufus. Fairly well, kind of this boundary of developing convection further to the west in the Davenport and Peoria area. So I would probably focus, if I was chasing personally, I'd probably focus in this area, even though the outlook, I believe, is currently focused further north. So there could be a southward expansion of this tornado risk to include this area, and perhaps still including the metro region with the MCV that moves through with the morning convection is possible. That would be my guess, which this area is very good for chasing. Or at least minus perhaps dealing with some rivers or pesky river crossings if you do get far enough west. But I believe this area is fairly good for chasing. And the road network, I believe, is also fairly good as well. So it's a good area to chase.
Last thing I want to say, Drew, is you made my heart skip a beat. As a denizen of the Midwest, whenever I hear MCV, I get a little excited. So we'll see how that plays out. And thanks again for your forecast, my friend. Remember to check out those links in the description below and then watch another video.